You can treat this course as a step-by-step tutorial that makes you a master of all these concepts of electrostatics. Hi, I am Anupal Bharali. Many students find electrostatics a bit difficult. But don't worry, I'll teach you electrostatics in a special way, making it simple for you to learn it. This course is designed in a special way. It starts from the fundamentals, goes step by step into difficult concepts, but everything is taught in an easy to understand way. In physics, your concepts must be very clear. That's why in this course, I've given very clear explanations of all the concepts. And for each formula, I've highlighted the important points that you have to understand and memorize. This course also contains solutions of numerical problems with shortcut tips and techniques. This course will cover theoretical concepts, derivation of formulas, conceptual questions and their answers, numerical problems and their solutions. So this is a complete course. It covers everything. There will be some practice questions, there will be quizzes, there will be assignments so that you can self-evaluate yourself as you progress through the course. In this lesson, we want to understand what is electrostatics. We can say it like this: the branch of physics which deals with the study of charges at rest is called electrostatics. So that means, say we have some electric charges at rest. At rest means they are static, they are not moving. And we want to study their behavior. Then that branch of physics is called electrostatics. Okay. Now, the charges at rest are also called static charges. It's obvious, charges at rest, they are not moving, so they are static charges. That's why electrostatics is also called static electricity. Another name for electrostatics is frictional electricity. Now this name comes from that fact that static charges can be generated by rubbing one object with another object. In electrostatics, we study about the forces between static charges. Say if there are two or more charges, they will exert force on each other. So we want to study about those forces. Next, electric fields due to static charges. Now electric field is a new concept. We'll be learning about this concept of electric field in this course. And what is an electric field? That will become clear later when we go to that part of the course. Okay. Similarly, in electrostatics, we also study about electric potential due to static charges. Now here is another new term, electric potential. We'll be learning about electrostatic potential, capacitance and capacitors, combination of capacitors, that is the series combination of capacitors, parallel combination of capacitors. We'll also learn other related concepts like the relation between electrostatic potential and electrostatic field intensity, electrostatics of conductors, and potential energy of charges in electrostatics. So it's a long list. As you go through the course, you will realize that there are a lot of concepts to be learned here, a lot of new things to be understood here. Now, is electrostatics difficult to learn? This is a common question among students. Yes, this is true. Many students find it difficult. The reason is that it is quite different from other branches of physics like mechanics, ray optics, electric current, etc. Electrostatics is quite different from all those other topics. Here you have to imagine many things. You cannot see it with your eyes. Like in mechanics, you know this body is moving. And in ray optics, you can see that a beam of light is traveling. It is falling on a mirror and getting reflected, things like that. But in electrostatics, you don't see much. You have to imagine. It is more of a theoretical topic, a conceptual topic. So that's why again I will say Your concepts have to be very clear. You should concentrate in understanding the fundamentals of electrostatics. Okay, so that's all in this lesson. Let's go to the next lesson now. So this question says there's an electric field in the x direction. So electric field is along x direction. Then it says we move a charge of 0.2 coulomb. So charge is there, 0.2 coulomb. Then there's a mention of work done. So first think about what is the formula for work done. So we all know work done is force dot displacement. Now the value of work done is given, the value of displacement is given. Now about this force, what is the force on this charge Q? Which formula? Formula number 8. What was that formula? The force was Q into E, right? So if you think about it in the vector notation, the direction of force will be same as the direction of the electric field. So that means if the charge is placed here, this charge is placed here, the force on it will be along this direction, which will be Q into E. This is the force. Okay? Now the question says the displacement is at an angle of 60 degrees. The magnitude of the displacement is given to be 2 meters. That means S is 2 meters. So all these data are given. So we simply put it in this formula. So what we get? W equal to Fs cos of theta dot product. So cos theta. So W is given to be 4 joule. F is QE. Q is given to be 0.2 into E. This is the force acting along this direction. Displacement is given to be 2 meters. Theta is given to be 60 degrees. So when we solve it, what we get is 4 equal to 0.2 E. 2 into cos 60 is half, so this becomes 1. So E becomes 4 by 0.2. That is 20. So this is electric field. So this is Newton per Coulomb itself unit. If you see the options, the correct option is option D. So this is a very simple question. The level of difficulty is simple here. Say in this question, the equation number 8 was used, which is force is equal to Q into E. A charge placed in an electric field experiences a force which is given by Q into E. But with that concept, we had to use the concept of work done, which was there in the mechanics of class 11. So when they prepare a question on a simple formula of electrostatics, usually they will mix it with some other concept of some other chapter, maybe of class 12, maybe of class 11. And usually it is mixed with a concept of class 11. So that's why class 11 is important. Okay, class 11 is very important. Your concepts of class 11 mechanics, which is the foundation of everything, those concepts have to be very clear. So if your concepts of class 11 are not clear, must start learning them. From the electrostatics point of view, this question is very simple. But overall, you have to mix it with the concept of work done, which was in class 11, which makes it a little bit difficult. But still, this question is of the easy level. So let's take up few numerical problems on electric potential. This is example 1. So obviously this question will be a very simple question. So it's a very simple question. The question is, calculate the potential at a point P due to a charge of 6 into 10 to the power minus 7 coulomb located 18 centimeter away. So let's solve this question. To solve this question, the first point we have to understand is that in this question, the charge is a point charge. So its value is given, and the point where we have to find the potential is at a distance of 18 centimeter, that is, it is given. So since this is a point charge, so we have to use the formula V equal to KQ by R. This we must be able to recall in the exam. After that, it's pretty simple. K is a standard value. This you should memorize, and sometimes in the exam they give this value. Okay, but you should memorize. It's very simple. 9 into 10 to the power 9. Okay, then replace the value of K here. For Q, write this. For R, 18 centimeter, so 18 into, convert it into meters, because we are working in SI units. Your units must be consistent, right? So then you calculate this expression, you will get the potential to be 3 into 10 to the power 4 volt. If you observe, you will see that the numerical values that I have taken in this problem makes our calculation very simple. Say this is 9, this is 6, this is 18. So 18 by 6 is 3, 9 divided by 3 is 3, right? Then this 10 to the power minus 2, when it goes to the numerator, it becomes plus, so it becomes 10 to the power 11 minus 7, 11 minus 7 is 4, so 10 to the power 4. So potential is this much. Calculations very simple, formula very simple, so the question is very simple. That's the solution, right? So let's take another example of a numerical problem on electric potential. The question here is, 3 charges are placed at the 3 corners of a rectangle of sides 4 centimeter by 3 centimeter. So the diagram is given here. So at this corner there is a charge of 4 microcoulomb, here 10 microcoulomb, at this corner minus 6 microcoulomb, and the size of the rectangle is given. The longer side is 4 centimeter and the shorter side is 3 centimeter, right? Now find the potential at the 4th corner P. So we have to find the potential at this point P, this point, this is the corner point. Okay, we have to find the potential due to all these 3 charges. Here we have to find the equivalent capacitance between points A and B. There are 3 capacitors here, and each capacitor is of 10 microfarad. So when we look at it for the first time, these 3 capacitors seem to be in series, but actually they are not in series. See, we draw a series connection like this. So this plate of this capacitor is connected to this plate of this capacitor. There is nothing connected in between. Similarly, this plate of this capacitor is connected to this plate of the 3rd capacitor. There is nothing connected in between. So this is in series. But in this situation, since there is a connection between these 2 capacitors, there is an extra connection here. There is an extra connection here. So these 3 capacitors are not in series. So we cross this option out. They are not in series. And when we look at it, they do not seem to be in parallel. Now let's analyze the circuit. Now the trick to analyze a circuit like this is that you take these 2 points where there are multiple connections. This wire is there, this wire is there, this wire is there. So say this point is P, and say this point is Q. So now you see, at this point we can see that this plate of this capacitor and this plate of the capacitor, they are connected. Now you follow this path, so we come here, so that means this plate of the capacitor is connected to these two plates of the capacitor. So that means at this point P, 1, 2, 3, three plates of the three capacitors are connected. Okay, now consider this point Q. Here this plate of the capacitor and this plate of the capacitor, they are connected. Follow this path. See, this plate of the capacitor is connected with them. So this plate is connected to this plate and this plate. Now if you look at it, you can see that these three plates are connected and these three plates are connected. So if I draw it like this is one capacitor, this is second capacitor, this is third capacitor. All these three plates are connected and the other plates of the capacitors are also connected. So this point is point A, this point is point B. So this circuit reduces to this circuit. Now we can easily see that these three capacitors are connected in parallel, right? So the equivalent capacitance, C equivalent, will be the sum of these three capacitors. So the equivalent capacitance between points A and B will be C equivalent. If I call it, it will be 10 plus 10 plus 10. So that means 30 microfarad. So the answer to this question is 30 microfarad. That is, the equivalent capacitance between point A and B is 30 microfarad. Clear?